Welcome to This Explainer. Let's jump right in because today we are diving into a radically new way of giving instructions to your AI builders. If you've spent any time working with AI coding agents, you've probably felt the friction. So today we're looking at a methodology called Spec-First AI Building, and it's all guided by the Super Prompt framework. It's really about changing how we communicate with AI, literally from the ground up.
Let's start with a pain point I think we all share. Why in the world does your AI builder keep hallucinating edge cases? You know the feeling, right? You give it a task, it writes the code, but it just constantly messes up those subtle load-bearing rules. You end up going back and forth, correcting the exact same logical errors on the fifth pass that it really should have caught on the very first one. It is so frustrating. Well, it turns out the problem actually isn't the AI's coding ability, it's our instructions.
And that leads us to the massive paradigm shift that's going to frame this whole explainer. The idea is this: correctness lives in the executable spec, not in the code. A super prompt exists to transfer exactly that truth. Prose, as it turns out, is incredibly dangerous. When you just describe what you want in plain text, you leave way too much room for interpretation. An executable specification, one made up of decision tables, invariants, and golden fixtures, now that is your ultimate source of truth.
Okay, let's quickly check out our roadmap for today. We're going to cover 1. AI improvisation, 2. Meeting super prompts, 3. Build spec anatomy, 4. Composition rules, 5. Docstring drift, and finally, 6. The echo check review.
All right, let's hit Section 1, AI improvisation, the problem.
Let's look at why standard prompting usually leads to buggy iterations. Often, we hand an AI a snapshot of our existing code and just say, hey, build this or add this feature. But here's the catch. A code snapshot only shows what the code does. It never shows which behaviors are load-bearing. Handing an AI a chunk of code is basically treating software development like improv theater. You're forcing the AI to guess your intent. Every subtle bug it ships is really just the AI relitigating a decision you've already settled, but you just failed to write down as a binding constraint.
Moving on to Section 2, Meet Super Prompts, the solution.
We really need to draw a hard line here. A super prompt is absolutely not for fixing your current project. Think about a scoped patch prompt. That's what you use for making one verifiable change at a time to a living code base. The super prompt, on the other hand, is a binding legal contract strictly for fresh, clean room builds. If you try to point a massive build spec at an existing code base, you are inviting a sprawling, unreviewable reconciliation rewrite that is almost guaranteed to break fixes you've already applied.
But wait, here's a massive caveat. If you're still prototyping and you haven't locked down your edge cases, you are absolutely not ready to write a super prompt yet. You can't spec your way around decisions you haven't even made. If your behavior is unsettled, you need a design pipeline. You prototype to answer questions and discover edge cases, not to keep the code. Only when your decision tables stop changing and your test fixtures actually hold still do you graduate to a super prompt.
Okay, Section 3, Build Spec Anatomy, 11 sections.
What's really fascinating here is the rigid, top-down structure of the spec. Since a builder reads top-down, you have to walk it through a critical structural flow of constraints. You start with identity, who it serves, and its scale ceiling. Then, before anything else, you move to the absolute, non-negotiable rules, or invariants. Rules come before structure, where you demand a pure I/O-free core engine. Structure comes before behavioral tables. And finally, the whole thing ends with binding proof. These are your golden fixtures, inserted in line, acting as the ultimate test that the builder literally must pass.
This is absolutely brilliant, because replacing vague prose with exhaustive tables forces the AI to build exactly what you want. Take a state machine, for example. We make sure to emphasize explicitly illegal moves. Builders will naturally implement the happy path from a table, sure, but they only implement the rejections that you explicitly name for them. By calling out the illegal moves and demanding they return a very specific error shape, you completely lock down the system's security and flow.
Let's jump to Section 4, Composition Rules, Strict Formatting.
Writing a super prompt isn't just about what you include, it's about how you write it. You have to brutally enforce anti-patterns. For instance, never ever use quality adjectives like robust, secure, or production-ready. Why? Well, because if you ask an AI to make something robust, it's going to grade its own homework incredibly generously and just tell you it succeeded. Every quality requirement must be cashed out as a named, checkable artifact. You don't ask for secure, you demand an asserted rejection on an illegal state transition. See the difference?
So you absolutely have to follow these composition musts. Your super prompt has to be stateless, meaning it relies on zero past conversation history. You have to explicitly name past failures so the AI doesn't just go and repeat them. And this one is crucial. You must include an honesty clause. This explicitly permits and actually obligates the builder to tell you when platform limitations exist, instead of just silently faking a feature and leaving a total time bomb for production.
Next up, Section 5, Docstring Drift, a cautionary tale.
To really get why we're so strict about these rules, let me walk you through a fascinating little mini mystery. In a real system, an end-to-end test correctly asserted that a stale claim should be marked as outdated. This executable assertion passed in continuous integration for months, completely fine. But about 180 lines above it, a human-readable docstring drifted and falsely claimed the verdict should be contradicted. So, when an agent mined the repo to write a spec, it naturally read the human summary, the docstring, and copied the wrong instruction. Luckily, when the AI builder executed the spec's strict precedence tables, it got outdated and actually pushed back against the flawed spec.
And this case file proves a monumental rule for spec-first building. Mine assertions, not summaries. When you're mining an existing system, you have to rank your sources by executability. Code assertions that actually run, those are trustworthy because they're checked by CI on literally every commit. Human-written prose, design docs, and docstrings, those are checked by nobody, and they drift silently. If they ever conflict, the executable line wins every single time.
Finally, Section 6, Echo Check Review, Step 0.
This methodology completely transforms how you do your review loop. The absolute cheapest verification step happens before a single line of code is ever written. It's called Step 0, the echo check. You must require the AI builder to restate your invariants, your precedence tables, and its build order in its own words, just to prove it understands the contract. Think about it. If it misreads the spec here, it costs you exactly one message to fix. But if it misreads the spec and actually writes the app, that costs you a total rebuild.
So you run your prompt through this strict pre-flight checklist. Are the scale ceilings pinned? Are the invariants numbered? Is a pure core demanded? Now, using this methodology doesn't magically eliminate human review. Instead, it delightfully shifts it. The AI is going to absolutely nail whatever your golden fixtures pin down. Your review time shifts entirely to the architectural seams and the storage level enforcement. The tricky places where the visible tests might pass, but the deeper rule wasn't actually enforced.
As we wrap up this explainer, I really want to leave you with a provocative challenge, something to permanently shift your mental model before your next big build. Ask yourself, are you writing an executable spec, or are you just asking your AI to improvise? Stop relying on prose, start building exhaustive decision tables, and watch your AI deliver correct code on the very first pass. Thanks so much for joining me on this deep dive.